folks, David here with Terrain-Tronics. Every week I get asked about LEDs and to explain the basics, if you will. This is a datasheet that you can see here for a generic 3mm sized LED, one that looks just like this. And we're going to walk through the datasheet and I'm going to try and explain to you what it is I think about, what I worry about. So let me zoom in a little here. Here is the sort of drawing of the LED, right? This should look familiar to you. Red ones, blue ones, orange ones, green ones. And this is what we call a schematic picture of it. And if you think about how the electricity flows, it goes from one side to the other, from positive to negative. And this line is pretty important. It shows that electricity can't flow in the other direction. So bear that in mind. LEDs only work in one direction. And typically, the long leg is the more positive side and the short leg is the more negative side. There are some absolute maximum ratings they have for for diodes. And one of the things to look forward to here is the continuous forward current. You have voltage, you have current, and you have power. Okay, voltage is like water pressure, right? You know, you can have the faucet turned off, but there's still pressure pushing at that. And if you turn the faucet just a little bit, you know, water's going to come shooting out of it, right? Because it's under pressure. Same thing with electricity in many ways. So we say here the maximum forward current, so this is switched on, is 30 milliamps, and I want you to remember that number. This has to do with the actual quality of light and the angles you can see it from, not relevant for what I want to cover in this short video. This is the graph I want to show you. Forward current versus forward voltage, okay? And what I want you guys to see here is this is the voltage that's coming from your battery, for instance. So if you have a 1.5 volt battery, an AA battery that we're all pretty familiar with, you'll see here that zero current flows. And if zero current is flowing, there's no light, right? So that's why if you only use one battery, you'll never switch anything on. LED wise, but if you use two of them, so 1.5 and then another 1.5, so you have them in series, you get 3 volts. Look how much current can flow. It's actually way off the chart. So what this little graph is telling you, and I'm going to zoom out a little to show it once again, is that once this LED has enough voltage to switch it on, it could be like a crowbar, right? It could handle lots and lots and lots of current. But what happens is that absolute maximum current that we spoke about earlier, that's when the LED burns out, okay? That's when it gets so hot it just fizzles. CR2032 batteries like this typically have an inherent fault inside of them. There's something wrong in their construction, which means they're actually limited in the amount of current. So they can drop about maybe 5 to 10 milliamps of current. And so that would mean that it actually stays in the safe zone. The battery is kind of holding itself back from what the LED is capable of, right? But if you had something like a USB power bank that is designed to drive thousands of milliamps, amps of current to charge a phone and so on, you can very quickly see that if you had a 5 volt power bank, it would switch this on and just blow it to smithereens. If you're going to use CR2032 batteries and you're driving a single LED, hook it up directly. You won't get any kind of brightness control, but you know that you're not going to blow the LED. However, if you're going to drive it with any other kind of battery, even if it's still a 3 volt battery, like a pair of AA batteries or even a USB power bank somehow, you are going to need to protect that LED from overcurrent. And normally we do that with a current limiting resistor. That's a whole other set of YouTubes. There's plenty of them out there for that. Or you can use a Conway Castle board that I make here at Terrain-Tronics, which limits the current, controls it at all times, and also shares the same level of current as current mirrors across multiple channels of LEDs. And what that means is you can have a brightness control that controls 4 LEDs of the same kind, and as you turn the knob, the brightness will ride up and ride down with it. So something to consider for the future there as well. That's the end of it for now. Let me know if you have any more questions in the future, and take care. Thank you. Bye-bye.